Hello students, welcome to my YouTube channel Integrated Physics Studies IPS. एथिरे मु ऑलरेडी प्लस टू सेकेंड इयर सिलेबस कंप्लीट कर सारी एबे मु प्लस थ्री सीबीसीएस फिजिक्स ऑनर्स जीई आ एमएससी फिजिक्स ऑनलाइन क्लासेस रो वीडियोस अपलोड करुच्ची जदि भल लगिला ताले वीडियोस को लाइक कर देबा और चैनल को सब्सक्राइब कर देबो यू कैन शेयर इट विथ योर फ्रेंड्स आल्सो इट्स कंप्लीटली फ्री ऑफ कॉस्ट लेटेस्ट वीडियो नोटिफिकेशन पई बेल आइकन को एठी ऑल रे सेट कर देबो तापरे वीडियोज रो क्लैरिटी बढ़ाया पई गो टू सेटिंग्स क्वालिटी एडवांस उपरे क्लिक करी यू कैन इंक्रीज द रिजोल्यूशन सबू वीडियोज पाई पीडीएफ नोट्स मु पठेबी जोटा एठी ड्रॉप डाउन लिस्ट को क्लिक करी यू कैन गेट द लिंक फ्रॉम द डिस्क्रिप्शन बॉक्स तापरे मोर चैनल नेम को क्लिक कले सबू वीडियोज को मु यूनिट वाइज एच पार सिलेबस सजाई की रखिथिबी व्हिच यू कैन गेट फ्रॉम द प्लेलिस्ट एठी सर्च करि परिबो ओके थैंक यू हेलो स्टूडेंट्स आज रो टॉपिक रे हमें कंपाउंड न्यूक्लियस ए विषय रे पढिबा देखो ऑलरेडी हमें देखिला अबाउट द न्यूक्लियर रिएक्शन एंड इलास्टिक क्रॉस सेक्शन तो कंपाउंड न्यूक्लियस माने नारु जणा पडुची जे इट इज नॉट अ सिंपल टाइप ऑफ न्यूक्लियस सो कंपाउंड न्यूक्लियस एक्चुअली होची गुटे इंटरमीडिएट स्टेप when a nuclear reaction is taking place okay so यार primary evidence कोन compound nucleus रो actually this was developed by the discovery of neutron and its use as a projectile in the production of nuclear reaction okay from 1935 onwards आटा एक्चुअली डेवलप करथिले कंपाउंड न्यूक्लियस हाइपोथेसिस टा नेल बोर जे कि बोर्स एटम मॉडल भी देथिले हाइड्रोजन एटम पाई खास करी सो इट वाज ऑब्जर्व दैट हाई एनर्जी न्यूट्रॉन जदि आमे नउछु देन the total cross section for the neutron absorption and the scattering was of the order of pi r square जो थे कि r हेगला nuclear radius so for every low energy however okay high energy पाई तो pi r square किंतु low energy जदि नउछु the cross section is found out to be higher and approaching to a limiting value which is pi lambda cross square okay lambda cross कोन एठी it is the reduced de Broglie wavelength of the neutron or simply lambda cross is equal to lambda by 2 pi okay now these results were sought to be explained by assuming that incident neutron moved in an average potential well due to all nucleons in the nucleus which is shown in the figure and it is for an interval of time which is of the order of the order is given or written like this t is equal to the ratio of nuclear diameter with the neutron velocity nuclear diameter obviously तुम जानी छो फॉर्मूला आस्ता है 10 to the power minus 14 हेगला neutron velocity को 10 to the power 7 नेला so we are getting the time interval having order of 10 to the power minus 21 seconds and this is our potential well right up to this level we have the ground state which are filled or occupied okay so the motion of an incident neutron in an average single particle potential well which is shown in the figure is shown and we have here the energy function like this a hisabre energy function ta aschi okay which is above the ground state right acha tapare in this case the incident neutron would have a large probability of escaping through the nucleus without absorption okay probability by chance अछि जे ये nucleus रो बाहर को पड़ेबो without any absorption so the elastic scattering cross section which is sigma sc should be large while capture or reaction cross section sigma re would be quite low so in this picture sigma sc should be large sigma re should be very low now at very low energy kon huwe the capture cross section should however be relatively large since the neutron would spend a longer period of time near the target nucleus so sigma re should depend upon the ratio 1 by v in this case okay so at thermal energy ame dekhiba ko paiba je both these cross section sigma sc and sigma re should be comparable since both of these approaches the limiting value which is your pi lambda cross square. Okay, now the energy levels in this single particle potential well should be well separated, as we have seen in the figure, from one another, and the separation being of the order of 5 to 10 MeV. Okay, and there would be also some levels which are above the neutron separation energy, jodi ame yaku kahiba Sn, which are virtual levels. So the width of the level which measures the probability of its decay will be given by the symbol gamma, which is equal to h cross by tau. ଆମେ already tau ର value ପାଇଛୁ 10 to the power minus 21, so h cross by 10 to the power minus 21 nearly equal to 1 MeV, which is showing that the levels are quite broad. Okay, because ଏଇଟା ଆମେ କ'ଣ ପାଇଲା, width of the level ଯଦି ଆମର 1 MeV ହେଇଗଲା ତାହେଲେ ସବୁ level ଭିତରେ gap ଟା ବହୁତ ବେଶୀ ବେଶୀ ଅଛି. Okay, now when the energy of the incident neutron correspond to the excitation energy of one of the nuclear levels, then ଯଦି excitation energy ସହିତ neutron energy ପାଖାପାଖି ସମାନ ରହୁଛି ତାହେଲେ ସମାନ energy ହେଲା ବେଳକୁ ଆମେ resonance ଦେଖିବାକୁ ପାଇବା. Okay, so resonances would be expected to be observed in the cross section versus energy graph. Okay, so ଏଇଟା ଆମେ ଉପରେ figure ରେ already ଦେଖିଲା. ଦେଖ এই figure ରେ এই resonance peak ଟା এই peak ଟା ଆସୁଛି, right? So ଏଇଟା ତମର graph ଟା ଆସିଛି କେମିତି, resonance जो ଆମେ ଦେଖିବାକୁ ପାଉଛୁ, it is the graph of the cross section versus the energy, and these resonances should be widely spaced, having a separation of several MeV and large width of the order of MeV. Okay, and obviously at very low energy near the thermal energy, no such resonances would be expected. Kaiki? Because the neutrons of a few electron volts having energy cannot be expected to produce resonances corresponding to the levels with the gaps of several MeV. Okay, because thermal energy jodi asi jauchi ताले এই জায়গাରେ ନ୍ୟୁଟ୍ରନ୍ ର ଏନର୍ଜି ବହୁତ କମ୍ ରହୁଛି, few electron volts, ଆଉ ଏଟାକୁ ଆମେ କମ୍ପେୟାର କରିପାରିବାନି with several million electron volts ସହିତ, ତେଣୁକରି ରିଜୋନେନ୍ସ ଆସିବ ନାହିଁ. ମନେ ରଖ, ରିଜୋନେନ୍ସ ସେତେବେଳେ ହିଁ ଆସେ ଯେତେବେଳେ ଦୁଇଟା ଏନର୍ଜି comparable ବା nearly same ରହୁଛି. Okay, now however such a picture does not agree at all with the observed results. ଉପରେ ଯାହା ଯାହା ଆମେ ଏବେ ଦେଖିଲା discuss କଲା, that is the theoretical one. Observed result by experimentally ଯଦି ଆମେ ଦେଖିବା, actually on the case of neutron which is induced reaction, so କ'ଣ ହେଲା, in many cases the neutron absorption cross section are found out to be very large at thermal neutron energy, while the elastic scattering cross section is having a very small value, lower value. Okay, and it may be noted here that at these very low energies, the absorption cross section is due to the radiative capture, that is the neutron and your gamma. Okay, n gamma type of reaction, and the resonances are observed in most nuclei for both elastic scattering cross section, which is sigma sc, and the radiative capture cross section, that is sigma n gamma. Okay, so these resonances mostly appear at neutron energy jar value range ରହୁଛି ତାର 0.1 to 10 electron volt ଯାଏ, that is they are very closely spaced. Okay, এটা experimentally ଦେଖାଗଲା, and they are also found to be very sharp, having a width of the order of 0.1 electron volt, or in fact less than that. So these energies जोटा आमे देखिला बहुत क्लोज रोची गैप सेमानकर भितरे, एंड दिस ऑब्जर्वेशन एक्चुअली एई ऑब्जर्वेशन को देखि कि नेल बोर प्रपोज कले गोटे मेकानिज्म फॉर द न्यूक्लियर रिएक्शन इन द ईयर 1936, व्हिच इज नोन एज द कंपाउंड न्यूक्लियस हाइपोथेसिस. ओके, सो व्हेन अ न्यूक्लियर प्रोजेक्टाइल, सपोज आमे कहला याकू स्मॉल x, ओके, and this projectile is entering into our target nucleus, which is capital X, in order to produce a nuclear reaction. Then an intermediate stage will be formed before the production of the final product nuclei. Okay, এটা হচ্ছে यार concept. Okay, so final product nuclei যদি ଆମେ କହୁଛୁ capital Y ଆଉ small y, ତେବେ ସେଇ final product ଟା ବାହାରିଲା ପୂର୍ବରୁ ଗୋଟେ intermediate stage ଆସିବ. Okay, which is shown here. So x plus x is giving you C star, which is further giving you y plus y. Okay, and this C star is nothing but the compound nucleus. Okay, so the incoming projectile X quickly dissipates its energy as it enters into the nucleus X, which is of course our parent nucleus, and it merges with closely packed nucleons within it. So as a result, general random motion of all the nucleons in the nucleus will be disturbed, and each nucleon will gain some additional energy, but no single no single one of them will generally gain enough energy in order to enable it to come out of the nucleus. Okay, single भी जेकोसी भी particle ଏତିକି ବି energy ପାଇ ନଥିବ ଯେ ବାହାରକୁ ଆସିପାରିବ nucleus ରୁ. Okay, which is of the order of few MeV. But however, after a relatively longer period of time, କିଛି ସମୟ ପରେ, when a very large number of very large number of collisions among the nucleons takes place, okay, which may be of the order of 10 million, then ଏବେ enough energy ଆସିଯିବ. Okay, ସେଇ energy ଏବେ କ'ଣ କରିବ, nucleons କୁ ବାହାରକୁ ଯିବା ପାଇଁ allow କରିବ. They will enable the nucleons to escape from the nucleus, which then de-excites. Okay, or याको हमें कहवा it cools off to the ground state. So it may also be de-excited by an alternative process of emission of gamma rays. Okay, a process रे भी de-excitation हेई परिबो, and the whole process is similar to the heating of a drop of liquid containing large number of molecules. Okay, so when enough energy is concentrated on some of the molecules, then କ'ଣ ହେବ, ଏବେ evaporation ହେବା start କରିବ, and the drop will be cooled. Okay, it will cool off, right? So the process of emission of nucleon or a group of nucleons from the excited nucleus as mentioned above is thus similar to the phenomenon of evaporation process. Okay, এটা जो evaporation process हमें liquid drop model रे भी एटा पढ़िଛ. So the analogy between the two systems was one of the points which led the formulation of the liquid drop model, as I said. Okay, which is a nuclear model, right? Now, the composite system that is formed as a result of absorption of the incident particle, which is small x, by the parent nucleus, that is capital X, is known as the compound nucleus, jota होतला C star. Now, though it ultimately breaks up by emission of further particle, that is small y, or of a gamma ray. Okay, gamma ray भी ही पारे किंबा small y भी ही पारे. So it lives long enough as compared to the time taken by a nucleon of a few million electron volt energy in order to travel through the mean free path of collision between the nucleons in the nucleus. Okay, which is somewhat less than the order of the nuclear radius, but it is having the same order of magnitude. Okay, so actually देखा गले এই जो mean free path टा nuclear radius रो जदियो कम रहुची, किंतु तार order टा magnitude रे समान रहुची, right? So the mean time between the collisions is about 2 into 10 to the power minus 15 to 5 divided by 5 into 10 to the power 7, or simply 10 to the power minus 22 seconds. So the life of the compound nucleus is of the order of 10 to the power 7 into 10 to the power minus 22, so 10 to the power minus 15 seconds ଆସିଗଲା. And it may be noted here that the mean time for radiative transition within the nuclei is 10 to the power minus 13 seconds, which is much longer than the time for decay of the compound nucleus by particle emission. Okay, now the particle Y, which is emitted in the decay of compound nucleus, is generally different from the particle X, which enters the parent nucleus capital X. Okay, जो particle टा parent nucleus भितर पशिची resultant particle जोटा बाहरला small y ताठू एटा अलगा. Okay, so in the event of y being identical with x, we have inelastic scattering. Okay, elastic scattering रे अलगा अलगा हबो, inelastic scattering रे identical रहिबो. So the residual nucleus y will be equal to x star, and in this case it is the same as the target nucleus, which is produced in different energy state, right? Now in the rare cases in which the residual nucleus is identical with that of your target nucleus and is produced exactly in the same state as the latter, we get what is known as compound elastic or resonance scattering. Okay, এটা बहुत rarely हुए जो थे कि टार्गेट न्यूक्लियस सहित भी समान हुए आउ एनर्जी स्टेट भी तार समान थाए. So as stated before, the elastic scattering may alternatively takes place by action of nuclear potential on incident particle without the entry of X into capital X in order to form the compound nucleus, and this is known as the potential scattering and has a much greater probability than the other one. Okay, the previous one. Now since the compound nucleus is a relatively longer lived entity, I mean देखितला यार लाइफ टाइम टा बहुत बेसी बाहरची, so the nuclear reaction actually proceeds in two numbers of steps. Number one है the formation of the compound nucleus by absorption of incident particle by the target nucleus, and number two है the disintegration of the compound nucleus in a manner which is independent of the method of its formation into the reaction which is producing y and capital Y in a definite quantum state. Okay, now sometimes the residual nucleus capital Y or the daughter nucleus capital Y may be left in a higher excited state which may then boil off. Okay, what I mean cool up, boil off another particle Y dash to leave the nucleus as capital Y dash or capital Y prime, leading to a two particle emission process. So आमे देखिला कैपिटल X तापरे कैपिटल Y डैश आछी. ओके, जो थरे कि हमरो दुईटा पार्टिकल रो एमिशन प्रोसेस आसीगला X small y dash. Okay, दुईटा पार्टिकल होची कोन small y और small y dash. Okay, so the process may continue and another particle पुणी थरे y double dash भी आसी पारे एमिशन ही पारे from the excited one, that is capital Y dash, leaving the residual nucleus as capital Y double dash in the third stage. So এই হিসাবে গোটে series of particles ଆମର ବାହାରି ପାରେ. Usually ଏଟା ହିଁ particle ଆମର generally neutron ହିଁ ଥାଏ. Okay, which may be boiled off successively from a higher excited nucleus, right? So the two stages by which a nuclear reaction proceeds may be written symbolically as x plus x, which is giving you C star, which is nothing but the compound nucleus, and it is ultimately giving you y plus y or C plus y, right? Now according to Bohr, the two stages, there is the formation of the compound nucleus and its breakup into the disintegrating particles. Both these stages are independent of each other, and this is known as the independence hypothesis, and the decay of C star depends only on the properties of this C star and not upon how it was formed. So in other words, ଆମେ କହିପାରିବା since C star is a relatively long lived entity, so by the time it is ready to break up, it forgets as to how it had been formed. Okay, so interesting line गोटे जदियो एटा ब्रेकअप भांगिया ପାଇଁ रेडी अछि किंतु को हिसाब रे तयारी हितला ता संगरे यार किछि भी लेना देना नहीं. Now the probability of decay is equal to the reciprocal of the mean lifetime tau eta tome janicho of the compound nucleus. So if gamma is the width of the level, we can use the uncertainty principle, the Heisenberg uncertainty principle, in order to write gamma into tau is nearly equal to h cross, or gamma equal to h cross by tau. Okay, so we say that the width of the level is a measure of the probability of its decay, and actually the compound nucleus may decay by emission of different types of particles like y dash, y double dash, and so on, etc., leaving a different residual nucleus in each of these cases. So each of these has a different probability of occurrence. So jodi ame kohuchu gamma y as the partial width of the level for the decay by emission of y, then considering the various possible types of decay, we get the total width of the level gamma to be equal to summation over y, gamma y plus gamma of gamma. Okay, so it is equal to gamma y plus gamma y dash plus gamma y double dash, so on, and lastly we have gamma of gamma, right? So the relative probabilities of different types of decay are then given as eta gamma equal to gamma y by gamma, eta gamma no, eta y equal to gamma y by gamma, then eta y dash equal to gamma y dash by gamma. Similarly, last eta gamma equal to gamma of gamma divided by gamma. Okay, मन रखो एटा होची कैपिटल गामा, एटा होची स्मॉल फॉर्म of gamma. Okay, now because of the independent hypothesis, we can write the cross section for the process, that is x, x, y as the product of cross section, that is sigma x, for the formation of compound nucleus and the probability of its decay. So mathematically sigma xy equal to sigma x into eta y, or sigma x gamma y by gamma. Okay, and the above way of writing the cross section implies that only one particular energy state of C star is being considered. Okay, a case. Okay, there is only one resonance, and this is possible if the energy levels are well separated and also they are so sharp that they do not interfere with each other. So in other words, the mean level spacing capital D is much smaller than the level width, that is gamma. So we shall first consider such isolated levels. So the case of overlapping levels will be considered later. So up to this I have taken the compound nucleus from one book. Now this I have taken from another book. Okay, ଏଠି ମୁଁ तीनटा ବହିରୁ ନେଇଛି. ଏଟା ପ୍ରଥମ ବୁକରୁ ମୁଁ ମାନେ ୟାକୁ ଏକ୍ସପ୍ଲେନ୍ କଲି. ଏଟା ହେଉଛି ସେକେଣ୍ଡ ବୁକରୁ. एथिरे भी कंपाउंड न्यूक्लियस, एनर्जी लेवल्स, देन द लेवल विड्थ या विषय ब्रीफली देछि. ओके, किंतु को हिसाब रे कंपाउंड न्यूक्लियस रो फॉर्मेशन टा केमती हैला, काहे कि तार कांसेप्ट आसिला जो नेल बोर कांसेप्ट प्रपोज कले से विषय एते बेसी लेखिनी. ओके, एथिरे ब्रीफ देला या विषय फर्दर जदि देखिबा ताले देखो एठी लेवल विड्थ भी आसी गला. तबरे 3 नंबर बुक को एबे जीवा कंपाउंड न्यूक्लियस भितरे दिस वन. ओके, एठी पूरा पूरी याकू इलाबोरेट करिकी बुझेइछि ए बहिरे. ओके, एटा होछि थर्ड बुक. एनर्जी लेवल्स को अगेन ये एक्सप्लेन करूछि. लेवल विड्थ आसी गला. ता छडा कंपाउंड न्यूक्लियस रिएक्शन विषय ये डिटेल एक्सप्लेन करूछि, लाइक रिएक्शन टू रिजल्ट फाइनल स्टेट्स, compound elastic, compound inelastic, compound reaction, then also reaction to continuum without and with pre-equilibrium. ए हिसाब रे याको डिस्टिंक्ट करिकी, डिस्टिंक्ट प्रोसेस करिकी रिएक्शन गुडा को ये ए बही रे बुझेइछि, राइट. सो देखो तमे ए बही रो भी पढ़ी पारो. डिसइंटीग्रेशन आल्सो आछि कंपाउंड न्यूक्लियस रो को हिसाब रे आसिला. देखो ए बही रे याको बुझेइछि. ओके, डिटेल मैनर रे एज आई सेड. सो तमे ए बही रो भी पढ़ी पारो. ओके, सो आई सजेस्ट यू टू read from all these books that I have given in my PDF and make your note accordingly.
Thank you.